Blood and other bodily fluids contain dissolved ions, which are generally referred to as electrolytes. And the unit we use to describe the concentration of ions is known as an equivalent. An equivalent relates the charge to the numbers of moles. So, for example, 1 mole of sodium cation is equal to 1 equivalent, and 1 mole of calcium is equal to 2 equivalents. And that has to do with the fact that sodium has a positive 1 charge and calcium has a positive 2 charge. It actually doesn't matter whether the charge is positive or negative, it just matters what the absolute value of that charge is. So, for example, if we look at table 8.2 in the textbook, we see 4 conversion factors between moles of ion and their equivalents. And we've already seen that 1 mole of sodium is 1 equivalent of sodium, 1 mole of calcium is 2 equivalents of calcium. But here are 2 examples of anions. So 1 mole of chloride is equal to 1 equivalent of chloride because chloride has a -1 charge, and 1 mole of sulfate is equal to 2 equivalents of sulfate because sulfate has a -2 charge. Now, in IV solutions, rather than using equivalents, the unit milliequivalent, or 1 × 10⁻³ equivalent per liter, is often used. So looking at typical electrolyte concentration in blood plasma, see that sodium cation has a milliequivalent of 138 per liters, potassium 5 milliequivalents per liter, magnesium 3 milliequivalents, calcium 4 milliequivalents, for a total of 150 milliequivalents of cations per liter. That's equal to the milliequivalents of anions per liter. So this will always be the case. Whatever the milliequivalents of cations is, that will be equal to the milliequivalents of anions. And we look at the anions in blood plasma: chloride, bicarbonate, hydrogen phosphate, and then also proteins, which comes from the negative charge of the carboxylate group on selected amino acids. Table 8.4 of your textbook summarizes the electrolyte concentration in units of milliequivalent per liter for various different IV solutions. And regardless of the solution and regardless of its purpose, the milliequivalence of cation is equal to the milliequivalence of anion.